I will make sure to add more information in the description of this video down below. I'll make sure to post the settings that I've used for this printer, hopefully giving you a head start. This is the buffet that I have for you today. Pretty small buffet, but nonetheless it's a buffet. Prints to show us how fine of a printing quality can we expect, how high of a printing speed can we print, and what filaments can be printed. So let's dig in.
Several bad puns later.
PLA being one of the most commonly used filament materials, it made only sense that we would start with PLA. And this is a mechanical plier that uses a linear gear to move circular gears that are attached to gripping arms that opens and close. Beautiful design, and the mind-blowing part is that it prints as just one part. So it indicates those tight tolerances that has to be printed, and it did a fantastic job. Printed at a much finer 0.1mm layer height, the level of detail is just breathtaking. It makes everything take way longer to print, but it almost makes the layer lines completely invisible for the naked eye. This little boat is a typical benchmark to see the performance of a 3D printer. I printed many of these before that you can go and compare them to. This one I would say is a 7, maybe an 8 out of 10. There is some minor blemishes, but overall it's pretty good. Flexible filament is by far the most exciting filament in my opinion, and so having a 3D printer that can print flexible filament is really important to me personally. Now that's where the conflict starts, because most of the printers that I normally use have something called a Bowden extruder, and that's where you have the extruder motor, what pushes the filament forward, connected by a tube to the heating element where the plastic actually gets melted. That tube causes friction and is an indication to how well a 3D printer will be able to print flexible filament. Now on the Ender 3, that tube is pretty short compared to something like on the Creality CR10, and for that reason I was hoping that it would be able to print flexible filament better, and it did. I'm not saying that this is the best 3D printer for flexible filament, but for this frog, it totally worked. Nylon as well as ABS benefits hugely from having a heated bed, and this is where it was the only thing I could really complain about with the CR10. The heated bed takes forever to heat up, and when it does, it can only reach 85 degrees Celsius. And this is where Creality made the major upgrade with this one. And well, first they attached everything to the frame, so it's nice and compact, but more importantly they encapsulated the power supply, so there's no exposed mains voltage unless you open it, but I mean it's relatively safe. But the big upgrade is it's now a 24 volt system, so the power supply is 24 volts, which means that the heated bed will heat up significantly faster, and just based on my results it will reach a maximum temperature of around 110 degrees Celsius. The nylon print is a water bottle holder for your bicycle. This is the kind of indestructible nylon, you're not going to be able to break it. Perfect application, and the print itself turned out great, and a lot thanks to the heated bed, so perfect upgrade. The last filament I tested was an exotic filament that mimics the look of ceramic. The print itself I think looks okay. I may have used a slightly too high temperature. The bottom half I think looks very realistic, and I could totally see myself print a huge one of these and have it in my garden and make it like a Greek palace. You know, I was quite curious to see just how fast we could print something, because it's quite a bit smaller than something like the Creality CR10, and you have a Bowden setup, which is one of the advantages of having a Bowden setup is that you can print faster, and it would just be a fun experiment to see if it even would be able to cope with the speed, even though you would never print at these high speeds. I went to my 3D printer slicer, a software where one would prepare the print to be made, and I increased the speed to 120 millimeters per second, and that's what this looks like. The bottom half actually doesn't look half bad. The upper half does have some distortion going on, but I mean, it coped in less than an hour as 0.2 millimeter layer height. It's finished. Pretty cool. A couple of things I didn't like with the printer, because everything can't be positive. The build volume. The building volume is such a personal and subjective view. For most people, a building volume of 230 by 230 by 250 millimeters is enough. Personally, I wouldn't mind it bigger. It keeps it nice and compact, but for $200, within that price range, you're not gonna be able to find a printer with a larger building volume anyways. Sound levels. It's not particularly noisy. In fact, it was more quiet than all the other 3D printers I've tested before. It's just something I wish they would implement into all 3D printers to make them silent. And that's exactly what I've done to my second Creality Ender 3. There are some easy shortcuts to be made here. Install motor dampeners, replace a few fans, and you're done. I will make a video of how to make basically any 3D printer silent, so subscribe for that. It's a small one, but why not use the space here to have a second fan blowing air onto the plastic? Something I do wish they would include in the kit is a glass bed. The entire Creality CR10 series did arrive with glass beds, and it's something that can be very useful to have if you plan to print something like phone cases, where you want to take the advantage of a shiny bottom layer. This feels like very high grit sandpaper that does give your part a more natural look to what the rest of the print looks like. But on the CR10 you could choose whether you wanted to have it or not to have it. You see, I can only speak from my experience, and I have 6 Creality printers, 4 of which I use more than I like to admit. All 6 arrived in working order. This one is $200. Within that price range we have the Tivo Tarantula, the A88, 2 of the printers I've reviewed before on this channel. Printers that does not stack up to the quality control, arrives with open power supplies, which is dangerous and thus requires some modifications to work properly. Should the Creality Ender 3 replace the A88, the Tivo Tarantula and many other 3D printers within the $200 range? Absolutely it should. Should it replace the CR10? It's half the price, it has a better heated bed, it's more compact, smaller build volume. I still think the CR10 has its place. In terms of size, it's still an affordable printer. But looking at the overall performance and affordability, the Ender 3 is up there. You know, I get this question all the time. People message me through Facebook or Instagram wondering what would be the best 3D printer for me. And it's always the same question, it's just the budget that differs. For most people, the Ender 3 is gonna be a good choice. I really do hope you found that review helpful. That was my aim. And for the next video, hopefully it's gonna be another RC video. I made a 3D printed RC airboat, and hopefully I'm gonna get a chance to take this out on the water. And so, see you again in the next video. Have an awesome day. Bye.